Good morning, children. Welcome back to SPR online classes. So, in this session, let us learn about that is the separation of any components from a mixture. That is the first, the last two methods we still left. It is that is the chromatography and the crystallization. Okay. After this, let us learn how the water is purified with the help of any sedimentation method. Okay. So, dear students, we have learned about the evaporation process, sublimation process, how we are going to separate two immiscible liquid with the help of a separating funnel, and we have learned about the distillation method and centrifugation method and fractional distillation method. Okay, and here the centrifugation method. Here we can separate the components with the help of the filtration method also. Okay, so we all learned about the evaporation method, sublimation method, separating funnel, distillation method, centrifugation method, and a fractional distillation method. So today let us learn how can we obtain a pure copper sulfate from an impure mixture. Okay, so this we can learn with the help of a process called as a crystallization. What is the name of that method? That the name of that method is a crystallization method. Okay. So here we are separating a pure copper sulfate from an impure sample, or instead of taking a pure copper sulfate, here you can take a here we can separate a pure sugar from an impure sample. Okay, how we can separate the pure copper sulfate from an impure sample? That is with the help of a crystallization method. So dear student, we can get a solid, that is a pure solid, by a crystallization method. What is a crystallization method? The crystallization method that it is used for a separation of a, here we are going to separate a pure solid in the form of its crystal and from a solution. Okay, what is a crystallization? The crystallization method, it is the process which in where we are going to separate a pure solid in the form of its crystal. We are getting the pure solid, but in the form of any crystalline state. Okay, from a solution is called as a crystallization method. What is any crystallization method? The crystallization is a process which is used to separate. What we are separating here? We are separating a pure solid, that is in the form of a crystalline state. From where? From a impure sample or from a solution. Okay. So let us learn this activity with the help of let us learn this process with the help of an activity. Okay. Here what we have taken the sample, that is we are taken a impure sample from which we have to separate a pure copper sulfate. So here to carry out this activity, what we have to do? We have to take a 5 gram of Na, that is an impure sample. Okay. Here, what we have to do? We have to take a 5 gram of impure sample. Okay. And what we have to do? This impure sample we have to take and that we have to dissolve in a minimum quantity of water. Here we have taken a 5 gram of Na impure sample and it is dissolved. How we have to dissolve? By using a small amount of Na water. Okay. And what we have to do? Filtrate. Means here after dissolving what we are getting here the solid impurities we are getting, that we have to filtrate it. Okay. We have to filter the impurities and we have to collect here the whatever the impurities that they are in the solid form, that we have to remove it with the filtration. Okay. And only some of the impurities and collect the solution in a china dish, where we have to take that solution. We have to take it in a china dish. Okay. And what we have to do? We have to heat the solution. Okay. Here what we have to do? Here we can use the heating process, or here we can use the evaporation process. Why? To get a saturated solution. Means to make the solution as a saturated. Okay. So while we are heating, here we can go for the heating process, or we can go for, we can use that solution for an evaporation purpose. Okay. Heat the solution to get it as a saturated. In the form of saturated, we are getting the solution. So here what will happen? The solution, whatever the we are getting in the saturated form now, that we have to cover it. That we have to cover it with the help of the cover it with the help of a filter paper. And what we have to do? We have to leave it undisturbed. Okay, for a day at a room temperature. Here, to perform this activity, here we have taken a 5 gram of NNA impure sample, and that impure sample, with the help of using a small quantity of living water, that we have dissolved it in a water, and after the dissolving the impurities which is present in the sample, some of the impurities that may be removed with the help of a filtration process. Also, we have to filter the impurities and collect the solution in a china dish. Whatever the solution that we are getting, that we have to take in a china dish and heat the solution to get it as a saturated. Means here we have to heat the solution to get it in the form of a saturated form. Okay. And that saturated solution which is in a china dish, it is covered with the help of a filter paper, and after that what we have to do, we have to keep that undisturbed at a room temperature for a day for a cooling purpose. Okay. And the china dish which is covered with the filter paper, we have to keep that undisturbed. Okay. For cooling purpose, we have to keep it in a room temperature for a day. And what you are going to see that you are going to absorb a pure solid, that is a pure solid of that is the pure copper sulfate in the form of crystals. So after leaving it in an undisturbed for a day at a room temperature, you are going to see that the formation of any crystals in a china dish. So that is a pure copper sulfate. We are getting the pure copper sulfate in the form of a crystals. Okay. So here we have learned that what is a crystallization process. Here we are getting a pure solid. Okay, what we are getting? We are getting a pure solid in the form of its crystals. What is a crystallization method? What is a crystallization process? The process in which that we are getting that we are separating a pure solid. The whatever the solid, whatever the impurities we have taken, that is the impurities present in the sample. From that we are getting a pure copper sulfate. Okay, so the crystallization method is the process in which we are separating a pure solids, that is in the form of its crystal state. Okay, from a solution is called as a crystallization method. Okay, and here dear students, the crystallization method is better than an evaporation method. Okay, the crystallization method is better than the evaporation method because of a certain reason. See here we can note that the crystallization method is better than the evaporation method because some solids decompose or some solids like, that is sugar, what will happen? Get charred on heating. Means charred means it will get burned on heating. See here, Why it is better to go for the crystallization method? Some of the solid they will get decomposed or some of them may like a sugar. What will happen? It will get burned on a heating. That's why the crystallization is better than that of an evaporation method. And some of the here what will happen even after filtration we are getting impurities in the sample. Okay, some of the impurities which may remain in the solid, okay, even after filtration. So, solid, whatever we are getting solid, which may be not pure. Okay. So because of these two reasons, that is the solid it may get decomposed or it may be checked on heating. But at the evaporation or the filtration process, what will happen? Some of the impurities which may left in an solids. Okay, even after the filtration of the evaporation, so the solid whatever we are getting after the filtration, so that it may be not very pure. Okay. So here, why we are using this method to get a pure component. So whatever the sample, whatever the component we are getting, it may be not pure by a filtration method or by an evaporation method. That's why the crystallization method is better than the evaporation method. These two reasons you have to write. Okay, and then let us go for the application where we are going to use this crystallization method. Here, the crystallization method is used in the purification of a salt from a seawater, where we are using the applications of a here it is used in the purification of common salt from seawater, and it is used in the separation of alum from impure sample. So apart from this, it is also used to get a pure sugar from any impure sample. So here this method, it is not only we have studied that we can get the pure copper sulfate. It is also one of the applications. And here we can get a pure sugar from an impure sample. That is the second application. And it is used in the purification of any common salt from seawater. And apart from this can be also used in the separation of an aluminum from an impure sample. So these are the application you can write. So how we are getting a pure copper sulfate or a pure solid with the help of a which method? With the help of a crystallization method. Next, let us study Here, the next method is that the question is like this, or the is the dye in the black ink is a single color. So dear student, in the earlier activity, we have separated the dye from an solution, that is from an ink, with the help of an which method, that is an evaporation method. Okay, where all the water is removed and the residue, we are getting the dye has a residue on the glass watch. Okay, so please recall that in the earlier activity, so in which we have separated that is from the ink, we have separated a dye. Okay, here the question is like this, is the dye in the black ink is a single color? Means here we have to check or we have to identify whatever the dye we are getting here, whether it is made up of any single color or not. Okay, so this we have separated with the help of any evaporation, means from the ink we have removed the dye with the help of the evaporation, means here we have removed the water with the help of the evaporation process and we obtain the dye as a residue on the watch glass. So here whatever the dye we got known, whether it is made up of any single color or not, this we have to learn with the help of any which method? Here we are going to learn with the help of any chromatography method. So here what we are doing, here we are identifying the different colors present in a dye with the help of a which method? With the help of a chromatography method. Okay. So dear students, the chromo means the word chromo, it is derived from a Greek means color. This method it is used for the first time to for the separation of any color. So the name is like this, that is chromatography. Chromo means it is this word, it is derived from an Greek word. Chromo means it is a color. What is the meaning of chromo? That is a color. And this method it is used to separate. First time it is used to separate the separation of any color. That's why the name here we are getting that. Now, in this session, let us learn this chromatography method with the help of activity. That is, we have taken a sample, that is ink. Okay. So here what we have to do, dear student, we have to take a strip of a filter paper. Let us identify or to learn how many colored components are present in a dye. That is that in a black ink. Here to carry out this activity, the things required is a strip of a filter paper. This method also we have learned with the help of an activity. So what we need, dear students, we need a strip of a filter paper. Okay. And next, what we have to do, we have to draw a line, say about 3 centimeter on a filter paper by using a pencil. Here, the distance at the lower edge, what we have to do with the help of the pencil, we have to draw a line. Here, the distance is say about 3 centimeter. Okay, and what we have to do next, we have to take a drop that sample, that is a drop of a blank ink we have to place a drop of ink at the center of this line. Okay. What we have taken? We have taken a strip of a filter paper and with the help of a pencil we have drawn a line and we have taken a drop of ink at the center of the line. Okay. So here after that we need a glass jar here, tall jar, or you can take a beaker. So in the beaker what we have to take? We have to take a say about 1/4 of the beaker. It is filled with a water, or you can take a jar. Okay, and this strip of the filter paper we have to immerse in the jar. How we have to immerse it means the line, the whatever the line we have drawn on the strip of the filter paper now, it should be just above the water level. Here, with the help of the paper clip, it is introduced inside the jar. The strip of the paper, what we have to do after adding the drop of an ink, we have to immerse that in a jar or a beaker or a tall jar which contain a 1/4 of a water in it. And how we have to immerse that means the level of that is the line of the whatever the line we have drawn out, it should be just above the water level. Means this line should not be dipped or it should not be immersed in the water. Okay. So here see here, after placing that, after immersing this filter paper, strip of any filter paper in a water, what leave it for an half an hour. Okay, we have what we have to do? We have to leave it undisturbed for half an hour. And what you are going to observe here, see here. When it is immersed in a water, when it is placed in a, that is the lower edge, it is placed in a water. Here what will happen? No doubt the part that is the lower, whatever the portion which is immersed in the water, it will be wet. Means the filter paper it will get after it is dipping in a water. But what will happen? When we are going to leave it for an hour undisturbed, after that we are going to observe that the filter paper it will be wet up to a higher portion. Means say the filter paper, the water rises. What will happen? The water which we have taken in a jar, it start rising up in the filter paper. Means the water rises up to the filter paper. So here whatever the water it is going to start rising up, it is going to rising along with the dye particles. It start rising along with the dye particles. Okay, what will happen? So after dropping a drop of ink on this strips, here we have placed that filter paper in a jar in which we have taken a 30% of the jar is filled with the water, and then we have to the strip is placed in such a way that the level that is the line it is just above. It should not be immersed in any water. Means it should be just above the water level, and by keeping an undisturbed for an hour. After that, what we are going to observe here, the water start rises, okay, in the upward direction, and it is going to rise along with these dye particles, okay. And after that, what you are going to observe, as the water rises up, no, the dye particles also move along with the water particles, and after that we have to remove that filter paper and we have to keep it for a dry. And here we are going to see the result is like this. The three spots we are going to observe on the filter paper. This we know that what we have added here, that is a black ink. And the second spot, here we are getting the name of the second spot is a red spot, and the third one which is above the red spot, that is a blue spot. After removing that filter paper from the jar, we have to keep it for a drying, and here we can see that the ink drop, that is the black ink. This first spot is a black ink, okay, and the second spot it is a red spot, and the third one which is above the red spot, that is a blue spot. So by this we came to know that this black ink, it is made up of another two component, that is called as a red and the blue. So here, dear students, so the principles, see here, the principle of this method is like this. The colored component which is, see here the red spot, it is below the blue spot. So here, what is the principle behind this method? The colored component which is more soluble in the water. See, let us listen carefully. The colored component which is more soluble in the water, it move along with the water particle to a higher portion. And the component which is less soluble, it move along with the water to a lower portion. Why we are going to see it the blue spot to a higher portion, means it is soluble, means this particle or this component it is more soluble in the water. So the particle which is more soluble in the water, it move along with the water to a higher portion, and the particle or component which is less soluble in the water, it move along with the water to a lower portion. Okay, so this is the principle behind the chromatography method. Is that clear, students? Is the dye, that is the black ink, is a color, whether it is made up of a single color or not. We came to know that it is this black ink, it is made up of a two color. One is a red and blue. Mean when we are going to mix these two solid particles, we are getting a liquid, that is we are getting a which color, that is a black color. Okay. And this chromatography method is used. Now let us learn the application of the chromatography method, where we are going to use this method. Uses of this method, okay, that is uses of the chromatography method. Here the what is a chromatography? So the chromatography is a method which is used, means here it is used for the separation of the solutes, the separation of the some of the solutes that dissolves in a same solvent. Means what is a chromatography method? This method, the process in which we are separating those solutes which that dissolves in a same solvent. Okay, that is what has in a chromatography method. And what is the principle behind this? The component, the colored component, which is more soluble in the water particles, it will move along with the water particle to a higher portion, and the colored component, which is less soluble in the water, it will move along with the water particle with to a lower portion. And now let us learn about the uses of the chromatography. Where we are using this chromatography? This we are using in the separation of a color. This we have learned in a dye, and it is used in the separation of a pigment from a natural color, and it is also used in the separation of a drugs from blood, and it is also used in the separation of a sugar from urine sample. What are the uses? This chromatography method can be used in separating color components in a dyes, and also it is used to separate a pigment from a natural color, and also it is used to separate a drug from the blood, and also it is used in the separation of sugar from the urine samples. So dear student, nowadays what happened? The technology has improved the chromatography method. So this about the chromatography method, you will learn more about this method in your higher classes. Okay. Is that clear about the crystallization and the chromatography method? So now let us learn about the water purification. We are learning how the water is going to purify from the water works. Okay. So with the help of the diagram, let us learn this. Here the water bodies, or say reservoir, the water bodies you can river, where the large amount of the water we are getting. This is connected to a again it is connected to the loading tank. Here the name of this tank is a sedimentation tank. Here, loading tank. This loading tank is connected to a filter tank. Again, this filtration tank is connected to a chlorination tank. What is the name of this tank? This tank is a chlorination tank. Here in this filtration tank, we can see the layers, 4 layers we can see here. And the first layer is a water layer and the second layer is a fine sand layer and the third one is a gravel layer. And the last that means it is a piece of a rock. Loose gravel. Okay. So here from the water body, that is from a river where we are getting a large amount of the water, which may not be river. From this, here supply water from to the sedimentation tank where it is allowed to here solid particles are allowed to settle down. Okay, and here in the loading tank, what will happen? Here we have sediment, the suspended impurities. From the water bodies, the water is passed to a sedimentation tank in which the solid impurities it is going to settle down, and the water from this sedimentation tank it is passed to a loading tank. Here the whatever the solid particles which are settled down now, again in this tank the here the some of the impurities which is passed to the next tank, that is a loading tank, in which the particles they are suspended here. The lighter particles they are suspended here, and what we have to do, we have to add a piece of alum, and the particles, impurities particles which are present in this loading tank, that is in the water, they are going to attach to the particles of any alum, and with the help of the gravity, what will happen? Again, they are going to settle down here. And from this, we have to pass it to a filtration tank, in which we are going to see a four layer. See here, a fine sand, that is a gravel, and the coarse gravel. Here, the role of the sands and the rock particles which help in the filtration of any water. We know that the sand is a natural, it will naturally purify the water, and along with the purification, what it will do, it will fix the bacteria, some of the bacteria. And water from this filtration tank, it is passed to a chlorination tank, where the bacteria, whatever the bacteria which is left, that bacteria it is killed with by adding the bleaching powder in this tank. The bacteria is killed here, and it is passed from a filtration tank to a chlorination tank. And after this, the water is supplied to a homes. Okay, so this how we can purify a water from the water workers. What we did here, that we have taken a water from the water bodies, say the river, where we are getting a large amount of the water. It is passed to the sedimentation, where the solid particles they are settled down, and that some of the lighter particles, the impurities particles, they are suspended. Here we have added a piece of alum. The impurities lighter particle, it is attached to the particle of the alum, and with the help of the gravity, it is settled down, and it is passed to the filter tanker for the filtration purpose. Here, the role, that is the sand, it will help in the purification of the water, along with by killing some of the germs. And it is passed to the next tank, which is a chlorination tank, where the bacteria are killed, and finally the water is supplied to an homes. Okay. So this is about how we can get the purified waters from the large water bodies to an home. So let us continue in the next class.
ಈ ತರನೇ